So good morning everyone. Today we are going to start with the class 11th physics, and we will begin with, first of all, what is physics. So physics has come from a Greek word which means nature, and as we all know that physics is a branch of science, and science itself is a Latin word. It has come from a Latin word which means to know. So when we study physics, it means that we want to know about nature, and we are going to study nature to study physics. So physics is the study of nature and the phenomena, a large number of phenomena that are happening in this universe. So we study those phenomena in physics. The thing is that there are a large number of phenomena that are happening in this world, but those all phenomena, they all follow certain laws, or they all can be explained using certain laws in physics. These are known as the conservation laws of physics. So we start with the conservation law. The very first law is the conservation of mechanical energy. Conservation laws. First is conservation of mechanical energy. The conservation of mechanical energy. In conservation of mechanical energy, we say that the total energy, if the forces that act on a system are conservative, then the total kinetic plus potential energy of a system is conserved. That is, kinetic energy plus potential energy is equal to constant. This is the law, the conservation of mechanical energy, provided that the forces that act on a system are conservative. Now we want to know that what are the conservative forces. So the forces are of two kinds. These are the conservative forces and the non-conservative forces. First, let us study about the conservative and non-conservative force. First is conservative force. A force is called a conservative force if the work done by that force depends only upon the initial and the final position. So if this is a body and we move this from this position to this position, this is the initial, this is the final position. So this is the distance, this is the displacement d. If s is the displacement, then work done by this force is equal to this force multiplied by the displacement. This is the work done, and it does not depend upon the distance, means it does not depend upon the path taken, means that you if you go from this initial position to this final position through this path or through this path, then the work done in all these processes will be same if the force is conservative. Also, here we want to say that if the work done in a closed loop, if you start from this initial position and you then come back to this initial position, means if the initial position is equal to the final position, then the work done should be zero if the force is conservative. So the work done in a closed path. The work done in a closed path is given by work done is equal to the integration of f dot ds. This is the work done in a closed path means, so we will draw a circle at the integration sign. So to show that this is the work done in the closed path, it only means that F into S, force into displacement it is, but we we are integrating it. This is a way. So because it is in a closed path, so because initial position is equal to final position, then this integration must be equal to 0. So in case of a conservative force, the integral, the closed line integral of force over that closed path is 0. So this is called a conservative force. And if this conservative force is acting on a system, then the total kinetic plus potential energy means the mechanical energy of the system is conserved. And the another type of force which is called the non-conservative force. So let us study about that as well. Non-conservative force. So in a non-conservative force, the work done that depends upon the path. Work done depends upon the path. This means that if we move this body from this initial position to this final position, then the amount of work which is done, it won't be same for this path or for this path or for this path. If we say this is path A, this is path B, this is path C, then the work done along path A is not equal to path B, is not equal to path C. Whereas in case of a conservative force, this work needs to be same, because the work done is path independent, but here the work done is path dependent. So if we say, so in this case, if we move from this initial position and come back to this final position, here the closed line integral of this force will not be equal to 0. This is in case of the non-conservative force. So these are two kinds of force, conservative and non-conservative forces. And for the conservation of mechanical energy, we need that the total the force that acting on a system must be conservative force. What does this mean? This means that, say, if there is a ball at a height h, there is a ball at a height h from the ground, then it's here the potential energy just before it is released from this position is equal to mass into acceleration due to gravity into its height above the ground. mgh is the potential energy that this ball is having, and at this point, just before release, its kinetic energy is equal to 0. It has 0 kinetic energy. So the total energy initially total kinetic energy plus potential energy is equal to mgh. Is equal to mgh plus 0 is equal to mgh only. And when it starts to come down, then what happens? The potential energy is slowly changing into its kinetic energy, and just before it hits the ground, whole of the kinetic energy, whole of the potential energy has been changed into kinetic energy. So here its kinetic energy will be equal to the potential energy. So its magnitude will be equal to mgh. Though this is not the formula of kinetic energy. The formula of kinetic energy is half into mass into velocity squared. But here I want to add that this is the magnitude equal to the initial potential energy, and then the potential energy, its potential energy just before hitting the ground is equal to 0. So this was the initial, that final. Finally, kinetic energy plus potential energy is equal to here potential energy is now 0 plus the kinetic energy is mgh. So the total energy, see, total energy, total mechanical energy, not the total energy, total mechanical energy, kinetic plus potential energy, total mechanical energy is equal to, initially it was initial, is equal to mgh is equal to final is equal to mgh. So during the whole process the total energy was conserved, the total energy was constant. If we say when the particle was somewhere like here in the middle, then its potential energy must have been equal to half mgh, and then its kinetic energy, if its potential energy is half mgh here, then its kinetic energy needs to be half mgh in magnitude. So this is the law of the conservation of the mechanical energy. But the thing is, the majority of the forces that are acting in nature, they all are not conservative forces, but there are non-conservative forces as well that are acting. So what are these non-conservative forces? An example of non-conservative force is force of friction. Here we say the ball is falling down due to the gravitational force, and the gravitational force is a conservative force. But one more force is acting when this ball is coming down, which that force is the force of friction due to the air. So here I want to say, so let me draw a new So when this ball is coming down, on the way we can say that there are air molecules here. So there is no vacuum, it is not in, the experiment is not carried out in vacuum, but there are air molecules. There are air molecules. So the air molecules, when the ball is coming down, they try to exert a upward thrust on this ball, and this ball comes, this ball pushes through the air, and there is a kind of friction between air and this ball, and therefore the whole potential energy is not converted into kinetic energy, but is lost during this process of friction in form of the heat energy or the sound energy. So when this strike with the air molecules, heat is produced and sound is produced. So the whole of the potential energy is not converted into the kinetic energy. Therefore we can say just before striking the ground, the potential energy is 0, but the potential energy is 0, but the kinetic energy, now the kinetic energy is not equal to mgh, but it is, kinetic energy will always be less than mgh. So here what we can say? We can say that the total mechanical energy is not conserved, because before and after, we can say before and after, the total kinetic plus potential energy has been is not same, because some of the potential energy has been converted to heat or sound energy. So therefore there comes the second conservation law, which is the conservation of total energy. So second conservation is conservation of total energy. So the total energy of the system is conserved. So here the same example, a ball is dropping down, it has been dropped down from height h, it is coming down, its potential energy is mgh, its kinetic energy here is equal to 0, here its potential energy is equal to 0, and its kinetic energy is, what is kinetic energy is equal to, say it is equal to x, which is less than mgh, so let the change in energy, the energy lost or converted to heat or so let the energy lost or converted to heat or sound be equal to small e. Then we can say that total energy, that is potential energy plus kinetic energy plus this energy lost is equal to constant, and equal to mgh in this case, is equal to mgh in this case, because at the starting initially kinetic energy was equal to 0, potential energy was equal to mgh, and E was equal to 0. There was no energy was lost when the process was start, just before dropping it, and afterwards finally kinetic energy is equal to x, potential energy is equal to 0, and energy lost is equal to E. So by the conservation of the total energy, we can say that x plus 0 plus the energy lost must be equal to mgh. And this is the second law. This is the law of the conservation of the total energy of the system. This happens because some energy has been lost during the process due to friction, due to a non-conservative force. So our next conservation law, we come with the third conservation law. Third conservation law is conservation of mass plus energy. So earlier it was assumed that energy is another thing, is a separate thing, and mass is a separate thing. There is no relation between mass and energy. So there were two different laws. One was the law of conservation of energy, which we have studied, and another was the law of conservation of mass. But the total mass plus energy of the system was conserved. Just like earlier the mechanical in the conservation of the mechanical energy, total kinetic plus potential energy was conserved. But if the forces acting were non-conservative, then the potential plus kinetic energy was not conserved, but kinetic plus potential plus the energy which is lost during the process. So the total energy of the isolated system was conserved. But now similarly we can say there is a relation between energy and mass, that is mass can be converted into energy and energy can be converted into mass, This is the relation between them, and the relation was given by Einstein, and the relation is this is a very famous relation, that E is equal to the change in mass into the square of the velocity c, where c must be, but the thing is that c must be comparable to the speed of light. So this is a law of conservation of mass plus energy. But in our daily experience, why we don't see this, why we don't see mass converting into energy? Why? Because in this relation c must be comparable to the speed of light, 3 into 10 raised to power 8 meter per second. This is the speed of light and the square of this. So the velocity must be, and the velocity of light is the maximum velocity of anything. It is the maximum velocity that any particle can reach. So nothing can move faster than the velocity of light. So this mass is converted into energy only when the speed must be comparable to this 3 into 10 raised per meter per second. Otherwise, this is so small, means this is almost negligible. That is why in our daily experiences, in our daily life, we don't see another law, that is the fourth law, that is conservation of momentum. So there is a law of conservation of momentum. But before studying the law of conservation of momentum, you must know what is momentum. We say that we denote it by P. We say that momentum is equal to mass times the velocity. But what is the physical interpretation of this momentum? So let us see. See if you are standing here and someone throws a very small ball towards you, then you can easily catch it. And if someone throws a very massive ball of huge mass, maybe the ball of iron, if he throws that ball towards you, then it will be very difficult for you to stop that ball. So the force that one needs to stop something, that depends upon its mass. So here it is, that depends upon this mass. On the other hand, we can also see that bullet. See, the mass is same, but it is a bullet, it is fired from a pistol. If this is a bullet which is fired from a pistol, then if you will try to stop this bullet, you will not be able to stop it. It will penetrate into your body or maybe cross your body. So, but the mass of this bullet is very small compared to this huge massive ball. But you can think of stopping this ball, but you cannot think of stopping this bullet with your hand. Why? Because it is having tremendous velocity this bullet is having. So now the force that is needed to stop an object, that also depends upon its velocity. And not just it depends, but it is directly proportional. So the force needed is directly proportional to M, and the force needed is also directly proportional to V. So now we say that the force needed is equal to, say, some constant, say alpha, some constant times mass into velocity. This is the force that is needed to stop. And if this constant is 1, then this force is equal to mv. This force is equal to mv, and we say this as momentum. This is the momentum. We can say it as, this is the force needed. The force needed to stop an object depends not on not just upon its mass but also upon its velocity, and the multiplication of these two factors, mass and velocity, that is momentum. So this is the force. If alpha is equal to 1, if this constant is equal to 1, then this force is mass times velocity, and this is the momentum that the system is having. So if mass is equal to 0, then obviously no force is required, m into v is 0. And also if the velocity is 0, if the velocity of something is 0, means it is in the state of rest, or it is in the state of rest. So if something is already in the state of rest, what does it, how can you stop it? How you need 0 force to stop it, because it is already stopped. So this is the physical interpretation of momentum. It is mass into velocity. And what is the law of the conservation of momentum? The law of conservation of momentum says that the total momentum of the system before and after must be same. So for example, see, if there is this marble, this is having mass is equal to m1, and there is this marble, this is having mass is equal to m2, and but this is, you throw this marble toward this marble, and this marble was at rest, and this marble you have thrown this marble toward this marble with velocity v. Here the velocity is 0. So what you will see, that after these two marbles strike each other, maybe that you sometimes see this marble 2 comes to rest, and this comes to rest, and this marble m2 starts moving. This marble m1 starts moving, so this will come to rest is equal to 0. Okay, and this marble will start moving with velocity v. This marble starts moving with velocity v, and here also if friction is not there, the non-conservative forces are not there, then you can see that the total momentum before and after. Before, the momentum was m2v plus 0. Initially the momentum was m2v plus 0 is equal to m2v, and finally the momentum was equal to m1, let us say this as v dashed, m1 v dashed plus 0, because now because this m2 has come to rest, mass is 0, so momentum is equal to 0, is equal to m1. So what does the law of conservation of momentum says? The total momentum before and after collision will be same. So m2v must be equal to m1v dashed. This is the law of conservation of momentum. This is a linear momentum, this is conserved. So there is another conservation law. Let us study about that. And the law is conservation of charge. The charge is conserved, and this is a very obvious law, because you see, charge can neither be created nor destroyed. So if you see, if there is a battery here, this is a resistance, this is a battery of V voltage, and due to this a current is flowing. So current I is flowing through this conductor, then here the current I enters this resistance, and you will see that if current I is entering resistance R, then the current I will also be leaving. So the thing is that what is current? The current is flow of charge. Current I is equal to the rate of flow of charge. Charge passing per unit time. We say it as dq by dt. Change in dq means change in charge with divided by the change in time. As what is velocity? Velocity is the change in distance with the change in time. Similarly, the change in amount of charge with the time is called current. So if the current entering is equal to current leaving, what does this means? This means that the charge entering, the rate at which the charge is entering is equal to the rate at which the charge is leaving this resistance. This means that the total charge, the charge is not accumulated anywhere in this conductor. The charge is not accumulated anywhere here in this resistor, in this resistance. So the charge which is entering is equal to charge which is leaving. What does that mean? That the charge is neither created here somewhere in this resistance, it is neither created nor it is destroyed, but the charge which is entering is equal to the charge which is leaving. This is an example of conservation of charge. So this is the conservation law of charge. Then if there is any other conservation law, then there is one more conservation law. We say it as the conservation of nucleons. The conservation of nucleons, it is essentially a conservation law of the conservation of mass. How? What are nucleons? The nucleons. What are nucleons? The nucleons are the particles. The protons and neutrons are the nucleons which are present in the nucleus. These particles which are present in the nucleus are called the nucleons. So the nucleons are conserved. The total number of nucleons before and after any reaction is conserved. How? You say, let us see an example of a decay. So uranium 238 92. This is the mass. This is the atomic number, means the number of protons. This get decomposed into thorium 234 and 90. So this is having mass 234 and 90 means number of protons are 90. And if this thorium 234 is there, so by the conservation of nucleons, total number of nucleons before and after must be same. Therefore, here there are 92. Here there are 90 protons. So we have to write here one more. It is helium, which is having 2 protons, and here we can say for its mass means 2 neutrons and 2 protons and 2 neutrons. So if we say that, if we can see here total number of nucleons. Initially it is equal to 238, and finally it is equal to 234 plus 4 is equal to 238. So 1 is equal to 2. This means the total number of nucleons before and after this decay has been conserved during this decay. This is the law of conservation of nucleons. So along with this conservation law, we will talk about one more thing. What is that? That is the conservation laws and the symmetry of time and the symmetry of space. What does it means? Say it is symmetry of time. First is symmetry of time. When we say symmetry of time means, you say, if you have this experiment, the experiment in which the VI characteristic of a ohmic resistor of an ohmic conductor was studied, and what was the result when Ohm studied this experiment? The result was this. He found out that at that time he found that the VI characteristic of a ohmic conductor is a straight line. This he found at that time, and it must be more than 100 years by now. And even today, if we do the same experiment, if we perform the same experiment in our lab, then what we will find? We will find that today also, let us say 100 years before. 100 years before, when this experiment was performed, this was the VI characteristic of an ohmic conductor. And today if you perform this experiment, you also know that definitely you will also get this same kind of characteristic. So this means that these laws has not been changed over time. Over 100 years of time, these laws have not been changed. This means that there is a symmetry of time. The conservation laws follow the symmetry of time, that whenever you perform an experiment, if the conditions under which you performed that experiments are same, then the results of the experiment are independent of time. That when are you even after 1 crore years also, if you will do this same experiment, you will definitely get the same result. Or if this experiment would have been carried out billions of years ago, billions of years before, then also the result must have been the same. Similarly, there is one another thing, that is we say symmetry of space. Symmetry of space, what does this mean? This means that this experiment VI characteristic, if you perform this experiment at your college, what result will you get? The same result. If you perform this experiment at your home, what result you will get? You will get the same result. If you perform this experiment on moon under same conditions, you will get the same experiment. If you perform this experiment at another end of the universe, even then you will get the same result. What does this mean? This means that the results of the experiments, these conservation laws follow the symmetry of time, as well as the symmetry of space. Means the results of the experiment does not depend upon where you are performing the experiment. If the conditions under which the experiment is performed are same, then the results must be same. And these are the laws of this. These are the fundamental laws of nature. These are the fundamental laws of nature. And any natural phenomena that is happening either on this earth, or on the moon, or on Mars, or on somewhere on the another end of the universe, all these phenomena must be following these 6 conservation laws which we have studied today. So after studying these conservation laws, we are going to study the types of forces that are there in the nature, the type of forces that exist in nature. There are certain fundamental forces that exist in nature. We'll study about these forces. Thank you very much for coming, for viewing this video up to here.